All right. Welcome, everybody. I'm Peter Klenk, Product Manager in IBM Cloud. And if you were with us last week, you heard a little bit of the backstory for how our software supply chains are at risk, how we're seeing some of those vulnerabilities exploited, and how it's really time to do something about it. And that we in IBM Cloud have built a reference implementation adopting DevSecOps practices aligned with various standards from NIST and others to help secure that software supply chain. So today is going to be all demo, and my colleague Steve Weaver is with us, and he's going to take us through that. So, Steve, over to you.
All right, thanks, Peter. Looking forward to this. If you remember last week, we talked a lot about what it means to build a secure software supply chain, and we talked about some of the challenges that development teams are facing, and some of the solutions that we at IBM have come up with in terms of our secure software supply chain reference architecture. As you recall, the reference architecture is implemented on the IBM Cloud as a set of templates in IBM Cloud Continuous Delivery. And that's really what I'm going to be taking you through today in kind of an example scenario. So we'll be taking those templates that you can see on the slide on the left-hand side here on the reference architectures and instantiating them in the IBM Cloud, and then going through kind of a typical process that a development team would go through to identify a bug in a running production system using the continuous compliance process, and then fixing that bug, delivering the change through the CI process, and ultimately deploying it into production with the continuous deployment process. So each of those pieces of the architecture will be exercised as we go through this scenario. So just to give you kind of an overview, a flavor for what you're going to see here in the next, 20-25 minutes or so. We have the continuous compliance pipeline that is automatically triggered, for example, every day, scanning our sample Node.js application and any of the associated artifacts that with it. As part of continuous compliance, we have a feature called IBM Code Risk Analyzer that's detected a new CVE risk inside of our running application in production. And the continuous compliance or CC pipeline has automatically created a new issue in our DevSecOps issues repository, and we'll take a look at that as we go through. So then the next step will be for us to fix that issue, and then start the process of building, testing, and deploying. So we'll make the code changes in our repository. We'll use a merge request to merge our code fixes to the master branch. And then we'll deploy it with continuous delivery. So at each step of the way, there'll be a number of processes that run to make sure that the software that we're delivering into production is secured at every step of the way. So with that, I will jump over to, I get the right screen, to our toolchains page. And before we get started, just want to remind folks that this is the IBM Cloud homepage. If I actually click up on IBM Cloud over here, when you first log into IBM Cloud, you'll end up on the Cloud dashboard. So we'll see that pop up here in a second. And the Cloud dashboard really gives you an overview of everything that you have running in the cloud. So you can see all of your resources over here, how many clusters I'm running, how many developer tools I'm running, storage, all that kind of good stuff. Any news, support cases, anything else right here in the Cloud dashboard. What we want to jump down into is our DevOps piece, our DevOps service. So if I go to the overview for DevOps, you'll see our homepage, and from our homepage, you can easily and quickly create a tool chain from one of our templates. As you can see here, there are a large number of templates that we have predefined to enable you to do a lot of pretty common things that you'd want to do with CI/CD systems. So, for example, we have a template that enables you to develop a Kubernetes app, paired with a slightly more complex one that allows you to choose your deployment strategy, whether you want, for example, a rolling deploy, canary testing, blue-green deploy, whether you want to deploy to virtual private cloud. We have one with to deploy to Cloud Foundry, microservices, build and test microservices, and a whole bunch of others. So all of these, provide a set of tools pre-integrated together out of the box. The ones that we're going to be focusing on here today, and if you want to, you could kind of follow along and do a similar scenario yourself. Are these three here? There's the three templates for CI, CD, and CC, continuous compliance, that we've talked about. So when you click on any one of these to instantiate the tool chain, what it enables you to do is to have a set of tools pre-integrated together to perform the tasks that you're going to see as we go through the demo. And you can see there's a kind of a guided path in here where you get to configure the tool chain for your particular needs. So, for example, you may already have your application repository, for example, in GitHub somewhere, either on-prem or on github.com. Same with an issues repository. You can use our secrets manager if you want. You can also use HashiCorp Vault if you want, and all that is configurable here in the wizard as well. So the end result of going through this wizard is that you'll end up with a set of tool chains that enable you to do continuous compliance, continuous integration, and continuous delivery. So I have these three already set up here, so that you can kind of we don't have to go through the setup, and we can get started right away. So as I mentioned before, we already have set up our continuous compliance tool chain, and you can see here all the components of it are set up in an easy to view dashboard. So we have a number of Git repositories that do various different things as part of our tool chains. So, for example, the Hello Compliance app repository contains the source code for our application. We have repositories that contain all our evidence. So every time something happens in our tool chain, so for example, every time a merge request is submitted, every time a scan is run, every time a test is run, all that information gets stored as evidence in our evidence locker, which is in this case a Git repository. We have an inventory repository too, which will tell us everything that went into building the version of our application that's in production. We also have issues database. So, if there are any issues that come up in the process, they're tracked in there. And we also have a pipelines repository too, which contains the source code for our delivery pipelines. And this is important because we can, as Peter mentioned last week, we can treat pipelines as code as well. So we can version control them, we can audit them, we can track them, all that kind of good stuff. So we know exactly how our software is being built. So the first thing we're going to do is actually go in and take a look at our issues database. And in our issues database, you'll notice that we have a bunch of issues that were caught when this ran automatically on a daily basis. So you can see that actually yesterday, when this ran, there were a whole bunch of issues that got pulled out by our scanning tools. So the idea would be that we would want to fix a whole lot of these particular issues, right? So, for example, if we take a look at one of these issues here, we can see that this issue was found by Code Risk Analyzer. And if we click on the link here, this will take us to the repository with the source code for this application. And it gives you an idea of what the problem actually is. If I go back to my, let's close that for a second. If I go back to my dashboard for my tool chain, and scroll down a little bit, I get to see the delivery pipelines that were created. So this is the pipeline that ran, that generated those issues. So if I open up this pipeline, what I'm going to be able to see here is all of the different steps that we went through with this continuous compliance pipeline. So when we pop this up, we'll see exactly what ran. So you can see we did some things like static and dynamic scans. We did some compliance scans as well. So one of the things we did was look for secrets in our source code. And this is things like finding passwords in our source code, things that shouldn't be there, right? And then we also ran Code Risk Analyzer. And as we were running Code Risk Analyzer, we do a number of different things. And I'll talk about this in a little more when we talk about scanning the source code. But we generate a bill of materials to identify every package, open source package that makes up the source code. We then run a vulnerability analysis, and in our vulnerability analysis, we picked up an issue that we created, and then we also do things like Terraform scanning as well for any infrastructure files that we may have. Here's our issue that we picked up as part of our run. So we have a direct link to the Snyk vulnerability database. Shows us exactly what the problem is with our code and how to fix it. So there's a lot of information there that we can find. So the first thing we need to do is really to go out, and if we jump back to our tool chain, go out to our source code and fix this problem, right? And that'll actually be pretty easy to do. So we'll go down to our Hello Compliance app repository, and we'll fix the problem. So in the real world, I'd actually go in and update some of our source code for a fix. I really don't have time to do that, so I'll just kind of demonstrate typically how that would occur. So this is all our source code in our Git repository. So let's go in and modify our Node.js app in here and just make a change. So we'll just do a fairly basic change in here. And in fact, maybe we'll just add a little more information, add more here. So nothing, not really doing anything major. What I am going to do though is provide a commit message. So update our file with new comments, and we're going to target a branch with demo4. And when I specify a target branch, this will kick off a new merge request for me. So if I hit commit changes, we'll see our new merge request in here, and I'll go ahead and create that merge request. So what this merge request will actually do is automatically kick off our pull request pipeline in our continuous integration tool chain. So you can see here, it's just starting off. So if I jump over to our CI pipeline, you can see that there are the same repositories as our CD pipeline, as our CC pipeline, sorry. But we have two separate PR pipelines now. One is our pull request pipeline that runs every time a merge request is submitted in our Git repo. And one is the CI pipeline that will actually build and deploy the app. So if we click on the PR pipeline in here, what we should be able to see is our PR pipeline has kicked off, and we can see that. So just creating the merge request automatically kicked off this PR pipeline. So we can see in here, if I click on this, and this will take a little while to run, but you can see the different steps that we're going to go through in here. So we're going to do some unit tests, and we're going to run CRA in here. So I'll go back to our pipeline runs, and we're just going to actually grab one of the ones that is already run in a minute. Before we do that, I just want to go into a little bit more detail on exactly what's in the pull request pipeline. So we talked about detecting secrets before, earlier when we ran the continuous compliance pipeline. We do the same in the pull request pipeline too. So the IBM Detect Secrets tool identifies where any secrets are visible in application code. So if we have API keys or passwords that are visible in the application codes, we will flag those as a problem. And then Code Risk Analyzer itself runs a number of different scans. A vulnerability scan that finds vulnerability for the app package dependencies. So we'll drill down, we'll create a bill of materials, we'll drill down to the bill of materials and identify any of the packages that we're using and whether there are any vulnerabilities associated with them. We'll also do a CIS check that runs configuration checks on Kubernetes deployment manifests as well. So a bunch of different things that happen with Code Risk Analyzer. One of the things that I didn't mention was Terraform scans. So if you have an application that you're building that requires infrastructure to be provisioned as part of that, then we'll also scan the Terraform files as well for any misconfigurations that may cause compliance issues as well. One thing to know about Code Risk Analyzer is it's available as a CLI plugin. So what this means is that it's very easy to embed Code Risk Analyzer into your existing tool chains, right? So we provide the templates with things like our own delivery pipelines and our own Git repos. But you can use whatever CI/CD tools that you're currently using, and then plug in Code Risk Analyzer via the CLI in order to leverage some of that capability. So what I'm going to do now is jump over to one of the PR pipelines that already succeeded. So here we go, and we'll see all of the different tasks we're able to complete successfully, including CRA. And you'll notice as we scroll through the logs here that we've done analysis of a number of different files, including, for example, in here, the analysis of the Docker file, the vulnerability scans, and we've scanned 440 packages as part of this application, and no vulnerabilities found. And then all of the test results are uploaded to our DevOps Insights tool, which provides dashboards so that you can see the progress on a build by build basis. So all the information is kept in here. So what I can do now is go back to our repo and take a look at all our merge requests. So here's the one that's currently running, which is not completed yet. The one that I just showed you ran a little while ago, and we can see that the pipeline passed for this particular one. So we can now go ahead and merge this request. If the pipeline failed, you would not actually be able to merge this request. You'd have to go and make changes to it. So if we hit merge here, so we will kick off the CI pipeline automatically. So if I go back to our pipelines page, or our toolchains page, and this time take a look at the CI pipeline, we will notice that has automatically kicked off in here too. So with the CI pipeline, we're doing a little bit more. So here's the one that we have just kicked off and just started. Here's one that I ran a little while ago. But in this CI pipeline run, we do a whole lot more checks, right? So we do similar unit tests, static scans, and our compliance tests that we did before, including running CRA again. But we're also containerizing, building and containerizing our application. And then we're also doing artifact signing as well. So we will sign all of our images to make sure that when we deploy them, that those signatures match. It's another aspect of securing the whole process. In addition to that, we'll do some dynamic scanning in here. and to make sure that those all ran successfully. And we'll also do some acceptance testing before deploying our application into our test environment. Okay, so once that is done, what we will actually end up with, if we go back to our repository, let me just jump back in here for a second. Go back to our repository and get to our inventory. What we're going to see in here is all the information about the particular build of this application that was generated by the CI pipeline. So if I go into Hello Compliance app in here, this is the raw file that contains information about this particular application. So you can see it has a name. It's the Hello Compliance app. It has a URL which links to our Git repository and a specific build number. In addition to all of that, we capture things like the run ID. We capture the provenance of the application. So in this case, we're pointing to the image in our container registry and the signature associated with it. Remember, I said that we automatically sign the information or sign the image as we go back through the process. Okay, so our code is now in our master repo. What we're going to do now is actually deploy that code out into production, and there's a couple of steps that we have to go through in order to do that. So the first one is to take our code and deploy it from fix from master to production. So we do that with the CD toolchain, our continuous deployment toolchain. And again, you see the same set of repositories in here with a different pipeline. We have a CD pipeline associated with it. So if I click on the CD pipeline, I can actually go and promote our code fix using the manual promotion trigger. And this will actually generate a merge request for me to promote from the master to the production branch. So if I hit run in here, this will actually run pretty quickly because all we're doing is creating a merge request to move it from master to the production branch. So if I click into here, this will kick off fairly soon, and we'll get started with the promotion. Peter, any comments as we're waiting for this to run?
Not really, Steve. I think you walked through a lot here, and a couple things that I think are key. For example, is putting things in the developer context. One of the problems I mentioned last week was the organizational disconnect and distance sometimes between the security focals who, are well versed in all the CVEs and where the priorities are, and then the developers that need to remediate them. So it was really key that we don't want to take the developer out of their context when we are asking them to fix CVEs. So the fact that, this toolchain puts those in the developers Git repo as issues, they can prioritize that along with all their other work. We talked a little bit about bill of materials. I think this is becoming well known, right? That really for all the components you produce, as well as for the components you consume down the road, having a bill of materials to understand what went in is really key, because as new vulnerabilities are found, we can reason about these bill of materials, and we can, identify common patterns across your organization. These vulnerabilities appear in many, many places because we can look at all the SBOMs and see what's popular. So your priorities as far as what to remediate and when and how much budget to dedicate to remediation could be different because of what's popular across your projects and applications. So the bill of materials we generate is SPDX. A lot of tools emerging to convert between that and Cyclone DX if you have a preference.
Absolutely. And we also talked a little bit about evidence collection there as well. Everything that we've done as part of the process is collected in our auditable evidence lockers, right? And as we'll see in a second, when we deploy our tool, all of this evidence is actually attached to a change request, which is generated when we do the deployment. And then the summary is also submitted to the IBM Security and Compliance Center. So, we have another dashboard there that security folks will typically, use to make sure that all of the applications that are running are secure.
So we got a question
Okay. Yep,
while we
go
were
ahead.
talking about AIX and the I series. So just to be clear, everything we're seeing here is running in IBM Cloud, and we're doing essentially Linux builds of this Hello Compliance app. And the builds themselves are running in managed pipeline workers that we run in our cluster in the public cloud on Linux underneath. So the techniques, 100% applicable across other architectures. I need to get back to you on the status of iSeries availability in public cloud. Don't know off the top of my hand. So, for certain tasks that we're showing in these pipelines, such as source scanning, looking for open source consumption, looking for known CVEs in that open source, looking at Terraform files for infrastructure configuration, that's applicable whatever your deployment target is, and you can run those parts of the process. Running the actual AIX build probably is going to run elsewhere. Need to run an AX machine in iSeries, so that would have to be tied into the other elements of the workflow. We have not packaged that up yet, but happy to explore that more offline.
Yep. So just to kind of wrap up in the next couple of minutes, so that the promotion pipeline is run and it's generated a merge request for us to promote from master to prod. You can edit this merge request, so you can provide, for example, in here a priority for the merge request. We'll just say this is moderate. You also provide information about who it's assigned to. Let's just put me in there. And then you can submit this merge request. And again, if I just, here's all the details, and hit merge, we can now go back. Now that the merge request is done, we can go back to our pipeline and run our deployment trigger, our manual CD trigger here. It will actually deploy our application out into production. So I'll just hit run, view the pipeline run for the CD pipeline in this case. And again, in here, you will see a number of different tasks that are more related to deployments, right? So I'll go back to my pipeline runs table. There's one I finished earlier. And show you all the steps in here. One of the main steps, other than deployment, right, and acceptance tests, we have to make sure that it runs successfully, is generating a change request record, right? So that's part of what goes into here, and we make sure that all of the evidence that we've collected is linked into this change request. So if I click on the URL for the change request here, what you're going to see is, every time we go through this process, we get information associated with the change request. So we have an evidence summary in here showing you the deployed items. We have a deployment bill of materials, and an inventory list as well. So each one of those is linked in here. So you can link directly to the deployment bill of materials, to the evidence summary, and to the closing summary. So all of that information is kept in one place. So once everything has been deployed, if we were going just to close the entire loop, if we were going to do that, then we would go back to our CC pipeline, and instead of waiting until tomorrow for it to run with our time trigger, we could actually run it again manually in here and run our CC pipeline just for the error that we had in the previous run no longer exists, just to completely close the loop. So with that, that pretty much wraps up the demo. I just wanted to leave you with this chart, which kind of shows you for each of the different pipelines that we've seen as part of this process, which checks are run at each stage, right? So you can see that in the pull request, we do a number of the the code risk analyzer checks, like the vulnerability scans, CIS checks, and so on. Continuous integration does all of those plus more, including building and signing the artifacts, running acceptance tests, dynamic code scans. Continuous delivery again does the similar things, from a dynamic perspective in terms of acceptance tests and so on, and updating the evidence repositories. And then compliance runs a subset of those too on the running application. So we are very careful to choose exactly which tests and checks are appropriate at each step along the way. So given that, I think we've seen a fairly simple end-to-end example of how we find an error, we fix the error, and then we propagate the fix into production, making sure that we're doing vulnerability scans, security scans, and collecting evidence at every step along the way. So hopefully these two parts, these two sessions, you've been able to get a good feel for everything that we do. For more information and to dive a little deeper into some of these concepts, we have a number of tutorials available in our IBM Cloud documentation at the link you see here. The IBM Center for Cloud Training has just released a new certification and curriculum in DevSecOps, which leverages a lot of the capabilities that you see in continuous delivery that we've looked at today. So certainly encourage you to take a look at that curriculum. And there are also blogs available on IBM Developer too that go into some of the details of the processes that we're implementing as part of our secure software supply chains. So with that, I think we'll wrap up. Peter, were there any more questions?
None that I saw, but thank you, Steve, for walking us through that. Thank you, everyone, for listening, and have a great day.